Hi, I'm Derek Melber, Chief Technology Evangelist for the Active Directory Solutions team at ManageEngine. In this video, I want to talk about passwords. And I want to talk about passwords both in where we're using them today, how they're being attacked, how we can secure them if we're going to maintain passwords, and then briefly talk a little bit about using multi-factor authentication to lose the reliance on only the password. In most organizations today, passwords aren't nearly as secure as they need to be, and really, in my opinion, they're almost never secure. So when we look at the reality of passwords, from the point in which passwords are created, I think they're insecure. Let's discuss that. Let's say it's Friday afternoon, and you get the email, and basically the email says that 20 new employees are starting on Monday. You wanted to leave, but of course you get the email at 4 o'clock. You're now not going to be able to leave until well after 4:15. So you have to sit down, create new users, and configure them so on Monday morning, those user accounts are ready to go for the new employees. So if we jump into the operating system here, in essence, what you do is you come over here to Active Directory Users and Computers. You go to the OU in which the new user is going to be located, and you create the new user account. So here you create whichever user is specified on your email, and then you have to put in a password for 20 new users. This is where often we use the same password. This is why I'm saying at the very beginning, passwords are vulnerable to attack. So we need to really up our game with regard to passwords. But I'm going to be honest, it doesn't end there. Inside of Active Directory in the Microsoft ecosystem, we have other areas that make passwords vulnerable. For example, authentication protocols. Authentication protocols back from when Windows 3.1.1 was created are still supported and enabled inside of Active Directory. LAN Manager, NTLM, these are very weak authentication protocols. But it even goes beyond that. We have our password policy, and the password policy is also weak. It's weak because it's been the same for 19 years. We're pushing almost 20 years now. So if something is the same for that long, the attackers know exactly where to go to, take advantage of the system. So what are the attackers actually doing? What are the problems that we have with association to the LAN Manager authentication protocol with regard to these weak settings? Well, let's talk about those briefly. And then what I want to do is play match game and talk about how the weaknesses can be lined up with technologies that secure those weaknesses directly. So let's first of all talk about the weaknesses. The weaknesses really are exposed because attackers are using tools to break into our passwords. And it doesn't really matter which tool you use. There's many different tools that are available for the attacker to get in. I'm going to show you one attack tool called Kane. And Kane itself has the ability to go in, look at your password hashes, and then you can actually run attacks on those hashes. Dictionary attacks, brute force attacks. So these are some of the attacks, some of the vulnerabilities that are available. Now, if we go back and we look at what the actual password policy is, we can start to break it down. First of all, with our password policy, you'll notice that we have something called complexity requirements. What's that? Well, complexity requirements is when the user must have certain settings or controls around their password. There are 4 types of characters that you can put in a password: lowercase, uppercase, number, and special. The complexity requirement says you must use 3 of the 4. Well, which 3 do users always use? Of course, lowercase, uppercase, and number. So if we can force users to use special characters, that's going to help us, right? Also, you'll notice here that by default, we have a 7-character minimum password length. Well, let's just be honest. If your user has a 7-character minimum password, what's the length of the password? So I'll say it in unison, 7 characters. So we have these limitations. And if we now go back into our attack tool to crack passwords, and we look at a brute force attack requires this input. So if I'm the attacker and I have to input parameters, well, which character type am I going to put in? Everything but special. And what minimum length am I going to put in? Well, what I've seen over the years around Active Directory is most organizations have between 6 and 10 characters in their password. Now, what does this help me as the attacker? Everything that I can reduce the overall configuration of what I'm looking for saves me time. So this is where we're going to start. And what I want to do is I want to take the capabilities of a brute force attack. I want to take the capabilities of a dictionary attack, and I want to attack them. I want to add controls that are going to allow me to make these available and make the attacker make these configurations, which are going to take longer time to break into my passwords. And if they don't make the configurations correct, they're not going to get into my passwords because their attack doesn't include it. But there's other areas that we also need to consider with regard to breaking into passwords. And if we really look at what's attacked, the attackers are moving beyond brute force and dictionary attacks. They are using them, but they're doing even more. Now, if we look at a dictionary of what a dictionary attack is, they normally have between, at a minimum, 17 million words, sometimes up to 700 million words. But they're not using one dictionary. They're taking the same dictionary twice. So you no longer can just use 2 words together and make that secure. You can't, because the attackers have technologies to do that. But the attackers are also going in and looking at derivations, up to 100,000 derivations of a word. Now, what's a derivation? Well, a derivation is if the word is password, for the A, they're using an ampersand. For the S, they're using a $sign. Those are variations. So the variations are important, and the attackers have dictionaries that have all these variations. They're also looking for patterns, like QWERTY, right? All of these 1, 2, 3, 4, 5, 6. They're just looking for those variations, and they're padding that at the beginning and end of a password to help break into our passwords. And as you see, we go down and the attackers are looking at totally different areas. Look at the last bullet in the main section, user information. Attackers today, once they have access to a computer, are going in and scouring the user information, all of the cached and stored information related to the user of the computer, and creating a word list from that too. So these attackers are definitely sophisticated, and we need to have solutions in place that help break these attacks, okay? Now, let's talk about what Microsoft is doing in this area. If we talk about on-prem Active Directory, they're really not doing much at all. Sure, they are taking some of the Azure Active Directory technology and making it available back on-prem, but what does that look like? Well, that looks like this, which is Microsoft's Azure Active Directory password protection. Now, this is somewhat of a unknown environment, but let me explain what's going on. Behind the scenes, when you enable this, Microsoft produces a dynamic word list in the background. The word list includes about 500 words. Okay? Now, I told you that a normal dictionary has 17 million words. 17 million, 500. Okay? Big difference. So we're really not protecting what the attacker is going after. But as you see here, you can actually do a custom banned word list. Excellent. You can put in your own word list. So you can create a word list that's going to be more secure to defend against the dictionary attack. How many words can you put in that list? 1,000. So we're at 1,500 words compared to potentially a 700 million dictionary attack. It's really not the same. So this is a good attempt. It's a good start, but I don't think it's really where we need to go to actually protect our passwords. We need solutions that are going to work within the Active Directory environment on-prem and Azure in a way that users normally change their password, which is on-prem, and then we replicate up to Azure to secure both environments from these types of attacks. Well, I believe a solution like AD Self-Service Plus is the best way to go. You'll notice here that inside of AD Self-Service Plus, I can require special characters. I can include a dictionary. I can include patterns of words. I can make sure that if the user's password today is password 1, the next one isn't password 2. This is a way that we can work within the constraint of your existing password policy in Active Directory, whether it be group policy or fine-grained password policies, and we layer on top of that. When your user changes their password on-prem, that password is now pushed up into Azure, and it's a solid password. So now in both environments, we have passwords that are meeting certain requirements. Now, look, I don't want to know you and think that your users are going to be frustrated with this. They are. But watch this. What I can do is I can go in and I can give your user, right? This is a user that's logged on. When they change their password, I actually indicate for them what the password policy is. And when they put in their new password, as they meet the criteria, it checks that piece off of the password policy, allowing you to increase security and allowing your user to be successful with the new requirements, making it easy for them to understand what that new password is. So what I can do is I can require special characters. I can include a dictionary. I can include words that cannot be in the password. All of these controls help negate the current attacks that are going on. One-to-one relationship, increasing overall security. And AD Self-Service Plus is an all-in-one solution that allows you to increase the password policy as well as allowing your user to be successful in the environment for many different things. For example, here is my password policy enforcer that I just showed you, but you can also allow your users to reset their own passwords. So now your users have the ability to reset their own password right from the logon screen. So if your users don't know what their password is, right? So let's log off our user here, and let's say it's Monday morning, the user doesn't remember what their password is. What I can do is I can have the user reset their own password. This is all 100% associated with multi-factor authentication because we cannot allow users to reset other users' passwords. So we provide you with a variety of multi-factor authentication options that you can work best with your users on what you want them to do when they're resetting their password. Now, this obviously jumps into that next level. Maybe we don't want to rely on passwords anymore. Maybe we want the password to be easy and we're going to use the multi-factor authentication to be that second level. Well, we can do that as well. And in order to do that with multi-factor authentication, in AD Self-Service Plus, you have different levels of using multi-factor authentication. If you want to go all the way to the Windows logon, as you see here on the screen, you can do that too. And all of the options that I just showed you with multi-factor authentication here are available at the Windows logon, at access to applications, both on-prem and in the cloud, as well as inside of AD Self-Service Plus, for example, when they reset their password, or they change their password, or many of the other characteristics of what AD Self-Service Plus provides. So with a solution that's all in one, we're increasing password security to negate the common attacks. We're giving the user the power to know what their password policy is so they can be successful with a more stringent password policy. If you want to move away from that, not a problem. You can go directly with multi-factor authentication, and now your environment has an additional layer or layers of security to make sure that attacks are negated because now the multi-factor authentication is including the other factor, and a normal password attack is no longer relevant in your environment. So with these solutions, you now have the ability to either increase password security, and over time, as you get multi-factor, you can incorporate that wherever you want. But at the root, the core today, tomorrow, your passwords are secure, and then even more secure when you include multi-factor authentication. I hope this information was valuable to you. And for myself, Derek Melber, and the rest of the AD Solutions team, I want to thank you for your time. And until the next video, good luck.